I'm going to show you how to do an exponential smoothing model and then to use Solver to find the best value of lambda. The software I'm using makes a click each time I use the mouse, so it's kind of annoying, and if you're wearing earphones it may actually hurt, so you may want to turn your volume down a little bit. So the first thing I'm going to do is enter a guess at the value of lambda. So let's suppose I start with a value of 0.5. And then I'm going to start building my forecast for each period. So the first period, it's just what I observed. In the second period, I'm going to start using the exponential smoothing formula. So I'm going to multiply lambda times the current observation plus 1 minus lambda multiplied times the previous forecast, and there's the forecast for period 2. Now I'm going to copy that formula down, so I want to tell Excel that the reference to lambda is an absolute reference. I don't want it to change as I copy it down, so I put those dollar signs in there, and then I copy that down. There's a dozen different ways to do that. I'm just going to use fill down. And so now I have forecasts for each period. And then I want to compute the error. I'll start with time period 1, and I want to be careful here because the error for time period 1 is associated with taking the outcome for time period 2 and subtracting the forecast that I made in time period 1. So that's minus 10. And then I'm going to copy this down, and I only do it for the first 19 time periods because that last time period I've made a forecast in period 20, but I haven't seen the outcome in period 21, so I don't have a way of computing the error. Then the next thing I want to do is to square those errors, and so I will do that in the last column over there, and I will copy those squared errors down. And there I have those. And then the mean squared error is the average of those 19 squared errors. And looks like I've misspelled average. Let me try again. And that's even worse. And I'm going to take the average of all 19 of those, and I get that big number there. And then to get the standard error, I'm going to take the square root of that number, and it's 140. And remember, before when we were working with this same data set, we got a standard error of 132, and the reason why this one's bigger is because the value of alpha that we have is not the best value of alpha. So Solver is going to find that best value for me, and the way I do that is I select the Data tab at the top of the screen, and then I go over, and there's a button over on the right that gives me Solver. And the first thing I have to do for Solver, it says set objective. I have to tell it which cell it is that I'm interested in finding the smallest value for, and that cell is the standard error. It could be the mean squared error. One's the square root of the other, it doesn't matter. So that's the number that I want to make as small as possible. And then it asks me in the next row there, do I want to minimize or maximize that? And I want to make it as small as possible, so I select minimize. And then in the next row it says, well, what value or what cell do you want to adjust in order to make that smaller? Well, I want to adjust lambda. So I select the cell where I have lambda stored. And then that's all I really need to do. I can take the defaults on everything else. I usually turn this thing off right here. That helps a little bit sometimes to make the search go a little better. And then I just select solve, and then it shows me my solution, and I can look at the solution and I say, oh, lambda is now 0.27 and the standard error is 132, and then I have the option of keeping that solution or going back to the previous solution. And in order to keep it, I say OK, and I'm done.